There is going to be a quiz next Tuesday on the stuff we're learning. Don't forget to pick your class correctly. And then let's simplify this radical. All right. So okay, 650. When we reduce a radical, what do we always start trying by? 2. Does 2 go into 650? It does. 2 times what? 325. If you're not sure, divide it in your calculator, right? So 2 times 325, cross out the 650. Now 325, does that divide by 2? Well, 325 is odd, so it doesn't work. So let's try 3. Does 3 go into 325? I did it earlier. It gave me a fraction. That's not going to work, okay? So let's try 5. Does 325, is it divisible by 5? And it is. 5 times 65. So let's break this down. 5 times 65. Cross out 325. And then 65, does that break down by 5? It does. 5 times what? So 65 divided by 5 gave me 13. So this is 5 times 13. Cross it out. Now, who remembers the story from yesterday? What do I do now? What do I do in the tree? Okay, good. Here's a couple, right? Circle your couple. One of them, so sad, goes away. Don't want to talk about it. Now, you draw your square root, your radical. Remember, couples go out to the left. Loners stay in to the right. If there's more than one, you multiply. So 5 goes out to the left. And there's 2 loners, 13 and 2. 2 times 13 is 26. That's it. Okay? Now, everyone, you need your notes from yesterday. We finished the first page. So turn it over. Yeah, we did. Did you? Okay, well. So go to the page that says multiplication of radicals. Let's do that. Here we go. Now, we're going to breeze through this stuff. This stuff's not that difficult, I don't think. Okay? Ready? Stay with me. When you're multiplying radicals, it says to multiply the outsides first, and then multiply the insides. That's it. Okay? Look. Hey. So look at example 1. Outside is 2 here. The outside is 6 here. What's 2 times 6? 12, right? And then we're going to multiply on the inside. The inside is 3. The inside is 2. So inside times inside. What's 3 times 2? All right, 6. So it's 12 squared root of 6. The only thing you might have to do is reduce it further. Okay? Now, let's try to break down 6. What are the factors of 6? Does 2 go into 6? 2 times? Okay, I knew that. 2 times 3. Are there any pairs? So it's done. 12 squared root of 6 is done. If you could break it down, then you should break it down. But as it is, that's it. Try example 2. Outside times the outside. 3 times 4 is what? 12. 3 times 4 is 12. And then the inside, 6 times 2 is, it's also 12. So is that my final answer? Well, let's take that 12 and break it down, if we can. 12, does 2 go into 12? 2 times 6, and 6 is even. 2 times 3. Do I have any pairs? Did you say no? Yeah, there's a pair too. actually. Circle that 2. So I have a pair of 2, and what's already outside of the square root is the 12. So what do I do with 12 and 2? Multiply. 12 times 2 is 24. And my loner inside is 3. Okay? Can you do 2 problems on your own? I'll give you like 1 minute. Here we go now. See if you can do those 2. All right, 1 minute's up. Here we go. On number 1, on number 1 here, outside times the outside, what's 4 times 3? 12, okay? Inside times the inside, 5 times 5 is 25. Does 25 break down? It does. Good guess. Now, what times what is 25? 5 times 5. And if you notice that there's no loners, that means it was a square number. 25 is a square number. We should already know the square root of 25 is 5, right? So what do I do with 5 and 12? Multiply. Always multiply. 12 times 5 is 60. Cool. On number 2, if there is no number right here, what number is implied right here? A 1. I would suggest you write it. This is a 1. So outside times the outside, 1 times 4 is 4. Inside times the inside, 2 times 3 is 6. Can you break down 6? Put that away. 6 is only 2 times 3. There's no pairs, so that's it. Okay. Any questions on multiplying? It's outside times outside, inside times inside. Reduce it if you can. Does anyone still need this? All right. Multiplying a radical times itself. This should be really easy. Let's start this. What's the square root of 2 times the square root of 2? Anybody. What's the square root of 2 times the square root of 2? Square root of 4, right? So square root of 2, a square root times a square root, like inside times inside is square root of 4. What is the square root of 4? 2, right? It's just a pair of 2's. So my answer is 2. Now, if you read the little instructions, what does it tell us? If you have a radical multiplied by itself, it's going to equal what? The number inside the radical. So look, if I have a square root of 2 times the square root of 2, remove the square root and you just have 2. Here's why this works. A number times itself is called squaring it, right? And if you square root a square, they disappear, they cancel out, and you're left with the number that was underneath. Okay? So on the next one, square root of 12 times square root of 12, you don't even have to do any math. What is the answer? 12, because it's the same square root. It removes the square root sign, and now you just have 12. I'll give you 5 seconds to do 3 and 4. You're done, right? What's the square root of 3 times the square root of 3? 3. Okay, these are easier now, right? What's the square root of 37 times square root of 37? 37, okay? Does everyone hear me and understanding why? Square roots times themselves, remove a square root. Easy peasy, lemon squeezy. Flip it over. Let's talk about dividing. Dividing is kind of like multiplying. You do the outside first, then you do the inside. So divide the outside, then divide the inside. So on example 5, what's 4 on the outside divided by 2 on the outside? 4 divided by 2 is what? 2. What's 15 divided by 3 on the inside? 5. Outside divided by outside, inside divided by inside. What about example 6? What's 6 divided by 2? 3. What's 10 divided by 5? 2. On both of these, the square root has a prime number in it, so we don't need to break it down. You can't break it down. Okay. So that's it. I'm going to give you 1 minute. Try 5 and 6. Everyone's trying 5 and 6. Oh, gosh. All right, here we go. Number 5. If there's no number in front of the square root of 2, what goes right here? A 1. What's 8 divided by 1? Ocho. What's 4 divided by 2? All right. 8 square root of 2. Now, what about number 6? By the way, 2 is prime, so leave it alone. On the next one, 2 divided by 2, what does that give me? 1. And then 4 divided by 2 is 2. Now, if you have a 1 square root of 2, usually you just see it written as square root of 2. Okay, so that's it for that. Now, this next part is something you got to learn before you get into these higher level maths. Okay, so, all right, check it out. When you're dividing, okay, you can only divide by a whole number. Here's an example. I have a bunch of students, right? I could divide y'all into a group of 2, like cut y'all in half, meaning the number of students in half. 2 groups, right? That's a whole number, 2. We could divide into 3 groups or 4 groups evenly, depending on how many people are here, whether it's even or not. Here's something you can't do. I cannot break into groups of decimals. I can't make y'all into a group of 1.5 without half it. All right, we're not doing that. So again, on the bottom of every fraction needs to be a whole number. Okay, this is not a whole number. This is a square root, and square roots are irrational. So what we do in math, whenever we see a square root on the bottom, is we want to rationalize it, make it a regular number, make it a whole number. So this is called rationalizing the denominator. Does everyone know denominators on the bottom? It's on the down, that denominator, right? Okay, so here's what you're gonna do. How do I get rid of the square root on that 3? Is there a way to get rid of a square root that we just talked about? What? Well, here's what I mean. If I have a square root of 3, the way I can get rid of the square root sign and end up with a regular 3 is if I multiply by the exact same square root of 3. Okay, do you remember this? If you take a square root times the same square root, it removes the square root. Okay, so that's what we're going to do when we rationalize a denominator. So here's what I want you to do. Ready? Scratch out that equal sign. I want the square root on the bottom to go away, so I'm going to multiply by the exact same square root of 3. Cool. Since it's a fraction, if I do it on the bottom, I got to do it on the top. So it's going to be times square root of 3 on the top. Now, on the top, what is 2 times the square root of 3? Who thinks it's 6? Who thinks it's square root of 6? Who thinks? All right, so 2 times the square root of 3, since one is a regular number and one is a square root, they don't match. You just kind of stick them next to each other. 2 times the square root of 3 is literally 2 square root of 3, okay? Gosh. All right, so get 2 square root of 3 over, and remind me, especially you, put that in your hand over there, what's the square root of 3 times the square root of 3? What? 3, thank you. Remember, if you have a square root times the same square root, it gets rid of the square root. We just talked about it, right? Okay, now I know this looks like more complicated, but the bottom is a whole number. That's what we need, a rational denominator. The only other step you might have to take is, can this reduce? Now, 2 over 3 does not reduce, so you're done. That's it. Let's do 2 more together, and I'll let you do 2 on your own. Look at number 7. What? Okay, number 7. Does the bottom have a whole number? No. It's got a square root on the bottom. I can't have a square root on the bottom, right? So what do I multiply this by to get rid of the square root of 2? No, you. What do you multiply this by to get rid of the square root? The exact same thing you see on the bottom, right? So check it out. Scratch out that equals. I want to get rid of the square root sign, so I'm going to multiply by the same square root of 2. And if I do it on the bottom, I'm going to do it on the top. Okay? On top. By the way, y'all need to learn how to do this because we are not accepting decimal answers because we need nice, clean, radical, simplified form. Okay? So on top, 8 times the square root of 2 is regular number, square root. Take them together. 8 square root of 2. On the bottom, what's square root of 2 times square root of 2? Just 2, okay? Now here's the thing. Can I reduce this? The regular numbers, 8 over 2. What is 8 divided by 2? It's 4. So this actually does reduce to 4, and then write the square root of 2 next to it. That's it. Finish? Or keep working. What about number 8? So again, I'm going to get rid of that equal sign. I don't need it. I'm going to try to get rid of the square root of 3 on the bottom by multiplying by the same square root. So on the bottom, times square root of 3. If I do it on the bottom, I'm going to do it on the top. 9 times the square root of 3 is 9 square root of 3. Square root of 3 times square root of 3 is just 3 on the bottom. And then what's 9 divided by 3? Does that reduce? What's 9 divided by 3? 3, and then square root of 3 stays next to it. I'll give you 1 minute. Try 7 and 8. Okay, here we go. Everyone's trying 7 and 8. Sorry, my bad. 9 and 10. Try those on your own. Real quick, because we got another page of notes. Real quick, because we still got more notes to do. We're going to go over these answers right now, so you're going to miss it. All right, here we go. Number 9. Everybody. Number 9. How do I get rid of that square root of 2 on the bottom? What do I multiply by? Square root of 2 on the bottom and the top. The top gives me 7 square root of 2. The bottom gives me 2. That's it. Number 10. To get rid of the square root of 3 on the bottom, I do times square root of 3 times square root of 3. On top, I have 8 square root of 3. On the bottom, I have a regular 3, and it does not reduce. Okay? Any questions on those? Okay, flip it over. Last thing we got to do is talk about adding and subtracting. This should be pretty easy. Ready? Here we go. All right, on the last page here, adding and subtracting radicals. So look right here. Before we talk about radicals, let's go back in time and talk about variables. In the back, everybody. What is 2x plus 3x? That would be multiplying, but just adding them, what would it be? Okay, so 2x plus 3x is 5, and it's just x, not squared, because you're not multiplying. So do you notice when you're adding, the numbers in front add, but the variable stays the same? Okay, same thing with b. If you're subtracting, 7x minus 5x is how many x? 2x. Okay. Now, c is kind of a trick question. If I have 5x plus 3y, what does that give me? So it doesn't change. Like it's not 8xy because that you're not multiplying the x and the y. Think of it like saying 5 apples and 3 oranges. That doesn't make 8 apples. It doesn't make 8 oranges. They're not like terms. Okay. Remember, you can only combine like terms. So 5x and 3y, they're not like terms. So you just rewrite it because it does not add. Cannot combine unlike terms. So I show you that because square roots are the same way. You can only add the coefficients in front or subtract the coefficients in front, but the square roots stay the same. So here we go. Let's add these. 2 square root of 3 plus 5 square root of 3. What is 2 plus 5? 7. And then the square root is going to stay the same. You're only adding the coefficients, not the inside of the square root. So this is not 7 square root of 6. It's not 7 square root of 9. It is 7 square root of 3. Okay. On the next one, if there's no number in front of the square root of 3, what goes right there? A 1. So it's really 4 square root of 3 plus 1 square root of 3, which is 5 square root of 3. Okay. Same thing for subtraction. 5 minus 3 is 2. Square root of 7 stays the same because they match. 2 minus 1 is 1 square root of 3. Please remember, you usually don't see the 1 there, so it's really just square root of 3. All right, I'll give you a little bit of time. I want you to try these on your own, and we'll go over the answers in a little bit. So try 1 through 10, and we'll go over them together in 10 minutes. Give it a try. Give it a try. All right. Number one. Again, you're adding the numbers in front. 2 plus 4 is 6, square root of 3. Number two, 8 minus 4 is 4, square root of 5. Number three, 3 minus 1 is 2, square root of 2. Now, what's weird about number 4? The square roots don't match, right? So if these don't match, then you cannot add them together. You just rewrite it, okay? They do not match. Number 5. Now, on number 5, 2 of them match, but one of them doesn't. So just combine these. 2 minus 3 is negative 1, square root of 3. And then the one that's weird, that doesn't match, you can just bring it over. Minus square root of 5. Only combine the like radicals. Hey, all along, over here. Yeah, come on over. Now, number 6, 8 minus 7 is 1, square root of 2, but usually you don't see the 1. Usually it's just square root of 2. On number 7, they're all square root of 2, so you can add them all up. 3 plus 4 is 7, and 7 minus 8 is negative 1, square root of 2, which you're usually going to see as just negative square root of 2. Number 8, 10 minus 5 is 5, square root of 5. Now, these last two look like you can't add them because they're not matching. But look at this, 18 is not prime. Let's see if we can make a factor tree and break it down. 18 is 2 times 9, right? And 3 times 3. I do have a pair of 3, right? Pair of 3. Loner 2 is going to be 3 square root of 2. Now, can I add these together? This is like a 1. 1 square root of 2 plus 3 square root of 2 is 4 square root of 2. And then similarly on number 10, 27 can be broken down into 3 times 9 and 3 times 3. Pair of 3, loner 3 is 3 square root of 3 minus 1 square root of 3 gives me 2 square root of 3. So sometimes you have to break it down and simplify it before you can add them together, okay? So I'm going to pass out your assignment. You have tomorrow to work on it too, but I'll give it to you today.